Here we come to the example on page 19, in which a stunner jumps over a canal using his motorcycle. He launched at point O and then go through a projectile motion to the highest point A and then land at point B. Please note that here, in this case, the starting point and ending point are on the same level. So we are talking about the special case, in which the range formula and all those sort of formula about special case can be applied. So part A, what is theta if the range of the motorcycle is at a maximum? So we can find the range of the projectile in special case given by the formula R equals U squared sine 2 theta over G. To let R to be maximum, the value sine 2 theta has to be maximum. So we know that sine 2 theta is a maximum, and we know that the sine of a certain angle would be maximum, and its maximum value will be 1. So solving this equation, sine 2 theta equals 1, theta would have to be 45 degrees. This is the angle at which the range will be the maximum. Part B, assume that the motorcycle took off at 45 degrees. Now we really have a 45 degree. So let us change to 45. So the launching speed of the motorcycle is 125 km per hour. As you can see, this time is not a SI unit, which is not good. So instantly, I would like to change the launching speed to 34.7 meter per second in SI unit. And once we change the unit, we will forget about the number in kmh. So U is equals to the launching speed is equal to 34.7. Also, we can resolve the initial velocity into two components, 34.7 cosine theta, which is 45 degrees. This is ux. And then the vertical part, uy, is equals to 34.7 sine theta, sine 45 degrees. Here comes to the highest point, point A. At this point, the motorcycle would go horizontally. We would only have a horizontal final speed. There is no Vy. Vy is equal to 0. So what is happening is that after the motorcycle go up, it will decelerate. So it will go up slower until the upward speed becomes 0. And this is the moment when it comes to the highest point, and this is point A. So we would like to find the time taken to move from point O to point A. We can consider the vertical part of the motion. Vy equals Uy plus Ayt. And Vy is equal to 0. Uy is equals to 4.7 sine 45 degree times t. So solving this equation, t would be 2.503 seconds. So it takes 2.5 seconds for the motorcycle to go from the starting point where t is equal to 0, and when it reaches point A, t is equal to 2.5 seconds. Part 2, we would like to know what is the time taken for the motorcycle to move from O to B. That is, from the starting point, go through point A, and then to point B. We can see that in this example, we are talking about the special case. So it is symmetric about the highest point. So the time here would be equal to 2 times the time we spend from point O to A. So this path is symmetric with this path about the line that go through the highest point. So the time from O to B would be equals to 2 times the time from O to A. So 2 times 2.503, which gives us 5.06 seconds. Finally, the range of motorcycle. Now, may I remind you again, because now we are talking about the special case in which the starting point, ending point, they are on the same level. So we can directly apply the range formula. So R is equals to U squared sine 2 theta over G. So it is 34.7 sine 2 times 45 degree. So 9.81. This one give us 1, and so the range would be 122.7 meters. Finally, why did a motorcycle need to land on a ramp? There is a ramp here. Okay, why does it need to land on a ramp? Imagine if it is a flat ground. When the motorcycle comes down, it comes down with a downward velocity. And when it hits the ground, which is horizontal, it has to come to a stop. It cannot go further down because the ground is hard. So now, this is not good. The motorcycle will still have a downward vertical velocity after landing on the ramp. If it lands directly on the ground, the downward velocity will become 0 immediately. In that case, the impact force will be large, and the motorcycle will be injured. By landing on ramp, the change in velocity will be smaller because the motorcycle is allowed to go down a little bit further. So we can have a smaller change in velocity. As a consequence, the momentum change will also be smaller. By this equation, we can see that the impact force will become smaller. And this reduces the chance of injury. That's why for this stunt, it is designed to have the motorcycle being landed on a ramp, so that after landing, it can further go down a little bit to reduce the chance of injury for the stunner.